Hello everybody. So based on some questions I got from a student recently, I decided I'll make a video where I work some problems right off of MyMathLab, okay, about hypothesis testing. And I wanted to include these notes because, I'm trying to think of the best way to convey all the information that's involved in hypothesis testing, and it's fairly technical. There are lots of details. I've thought a lot about the best way to put it together. I've done it different ways over the years, but this is what I've decided on for now, so I hope it helps you. So there are some things involved in this that we won't talk a whole lot about in this video, such as the standard test statistic, but eventually we're going to calculate this thing called the standard test statistic, and then our procedure and results with hypothesis testing would be based on that number. For now, that will be given. We're not going to worry about it. Alpha is given, and that's the level of significance. So in hypothesis testing, there is involved a level of confidence about your conclusion, and that's what alpha represents. Okay, and we do our calculations in all cases based on the standard normal distribution, which is the normal distribution with a mean of 0 and a standard deviation of 1. Okay, so our three scenarios of hypothesis testing depend on the null hypothesis. Okay, so the null hypothesis is going by the symbol h with a subscript 0, and if h with a subscript 0 is a statement that says it's greater than or equal to a number, z will be negative, and that's called a left-tailed test. Okay, and things that will be involved in this is this critical value, which marks off this area being some number p, and we would reject the null hypothesis if z was over here to the left of the critical value. Okay, and that would amount to, we would reject if p, the area of this region, is less than alpha, which is whatever the given level of significance is. Alright, so that's the left-tailed test. Right-tailed test is just turned around. The curve looks this way instead of this way, but the concepts are the same otherwise. You'll have a right-tailed test if the null hypothesis is a statement that says h naught, h subscript 0, is less than or equal to a number. Z will be positive. Okay, once again, this critical value marks off the beginning of this area. This area is calculated to be p. We would reject the null hypothesis if z, which is the standard test statistic, is over here to the right of the critical value. That's the same thing as saying if p, the area of this region here, is less than alpha, we'll reject h naught. Okay, and then there's the two-tailed test, where we will be in that situation if h naught is equal to a number. And in that case, z could be positive or negative, the standard test statistic. Okay, but when we look on our standard normal curves, the area in either tail, okay, because we're going to have two tails here, okay, is p divided by 2. All right, critical value marks the beginning of each region. We would reject if z was to the left of this one or to the right of that one. Okay, but the area of each tail is p over 2. If you double that, you get p. If p is less than or equal to alpha, we reject the null hypothesis. Okay, so those are the three scenarios, and I know I read through it now, but I don't know that it really does that much good to read through it. I mean, I think we need to do problems, so I'm sorry if that was a mistake to read through it. So eventually I want to work up to doing a problem like this where I'm given an actual study and there's some data collected from the study and so on, and we want to make a judgment about some claim which turns out to be the null hypothesis. Okay, but that's not really where we should start, because we should learn about the technical details of the procedure. Okay, so here it says find the p-value for the indicated hypothesis test with the given standardized test statistic. So eventually we'll calculate the standardized test statistic, but not now. We're just going to worry about how you read these curves and you decide on everything that's in these pictures, okay? That's where we'll begin. And it says we have a right-tailed test with test statistic z is 1.33 and alpha is 0.08, okay? All right, so here in this one, we're dealing with this. Now again, the standard normal curve on which all calculations are based is the normal curve with a mean of 0 and standard deviation of 1. Given that z is 1.33 and that it's a right-tailed test with alpha 0.08. So that would look like this. And what that's asking is, if this number right here is 1.33 on this standard normal curve, then what is this area? That's what is meant by the p-value. So although like I think this might seem confusing when you first get into it, once you boil it down to what it's really asking, it might not be that difficult. All right, I hope that's the point I can get you to. All right, so here's how we need to address that. I need to take my standard normal curve, I need to fix this number at 1.33, and I need to find the area over here in this tail. All right, that'll be the p-value. So I'll go to stat, calculators, and then normal, and from there I want to put px greater than. That would make it a right-tailed test, and I wanted that, I wanted to calculate the area more than 1.33, so then I make this number 1.33, and then it tells me it's like this right here means that the area to the right of 1.33, where 1.33 is right there, is 0.091759. Okay, all right, and you can see that that is the number that I entered with some rounding. All right, okay, so so let's look at them together if you want to. 918 versus 9175. It said round to 4 decimal places. Okay, so I've got my p-value. Okay, p is equal to 0.0918 with a little rounding, and so that's what's going in MyMathLab. As far as the rest of the question goes, it says, okay, well, with that number, would you reject h naught, the null hypothesis, or would you fail to reject it? Well, let's go back to what my initial criteria were. So let's see, right-tailed test, okay, if p, the p-value is less than or equal to alpha, we'll reject h naught, okay? So the p-value has to be less than or equal to alpha. So I got p to be 0.09 and alpha is 0.08. It's not less, so we wouldn't reject. Okay, just based on the brute facts of hypothesis testing. So that's why I say fail to reject. Okay, this number, the p-value, would have to be less than this number alpha to reject the null hypothesis. All right, so let's try another one. Let's try one with a two-tailed test. So that'll be question 2. So here I'm given that we have a two-tailed test with test statistic z is negative 1.99 and alpha is 0.05. Okay. All right, so now part of what I want to do right now is just, you know, these are the only three scenarios of hypothesis testing that we have in assignment 4.2, and I'm just trying to get you to learn to read these notes I have on like what's the critical value, what do we mean by p, if we find p, how do you judge p is less than or equal to alpha, you reject it. I'm just trying to get you to be able to read all that, because you know, you take the test, you're going to have notes to guide you. It's not like you have to remember all this, but good notes are going to be, I think, absolutely essential for most people. So let's see if we can figure this out. I guess this question is asking that this area will be p divided by 2. It won't be the p-value. It will be the p-value divided by 2. And then I'm being told that this number, negative puts you on the left, because on the standard normal curve, the mean there is at 0, is negative 1.99. Okay, all right. So I need to find this area, noting that it's not the p-value, but it's the p-value divided by 2. I say that just because that's how the two-tailed test is set up. You know, there's the p-value for the hypothesis test, and the area in either tail is half of that. Okay, so that's why I put my notes to be the way that they are on this one. So let's do this. Let's open again StatCrunch, okay? And I'm just looking at it like this, and I'll say, all right, that will be P over 2. I'll find this area, it'll be P over 2. So to find this area, I'm going to put this to be less than. That would make it put on the left like that. And then my number is negative 1.99. Okay? And then I get this number, 0.0233. Okay? All right, so let me update that. Okay, so that area over there is 0. What was it? I always forget. 0.0233. 0.0233. Okay, and that's equal to P over 2. So I would find the P value by just multiplying this area by 2. So I get 2 times 0.0233. Okay? All right, so there we go. Now, that's how I'm getting this answer, 0.0466 for the p-value. All right, okay. So for a two-tailed test, I'm going to find that area. It's not going to be the p-value. It's going to be half of it. So I find it, I double it, right? And it's no big deal to do that. No big deal to double it. We can do that. Okay. And then we get our p-value. Now, conclusion. What do we say? That it's like ultimately in hypothesis testing, we're going to have this hypothesis, this claim about some scientific study of data, and we either reject it or we accept it. We either reject it or we fail to reject it. And you notice that in all of my scenarios where if the p-value is less than or equal to alpha, then we reject. Okay? So in this case, over here, I got P is 0.0466 and alpha is 0.05. So yeah, the p-value is less than alpha. All right. So that is the scenario where we reject the null hypothesis. Okay. Now you're going to have to imagine that in this bigger context of there's a scientific study and there's some claim made about the data, and that's the null hypothesis, and you're ultimately deciding about, oh, do I accept that that's true or do I reject it? But we're not there yet. I'm just trying to show you how to do the math that's involved in getting up to that point based on my 3 scenarios that every problem will fall into. Okay. All right, so let's see what else. Let's take this a little bit further. Let's do question 5 from assignment 4.2. So here I am back on assignment 4.2, and question 5 looks like this. It says find the critical value in rejection regions for this type of hypothesis test with the level of significance given. It said it's a right-tailed test with alpha is 0.7. Okay. So right-tailed test alpha is 0.7. So here's the way that I'm going to think about it. Notice that like in my notes over here, then I said, okay, well, ultimately the area in this tail determines if we reject the null hypothesis or not. If the area in the tail is P, and if P is less than or equal to alpha, we reject the null hypothesis. Okay? If it's not, then we wouldn't reject. Anyway, so, but beyond that, like there's this beginning of that region that we call the critical value. And if Z was over in this region, then it would just shrink this area, and all the more P would be less than alpha and you would reject. So like the critical value is where the rejection region begins. Okay. And remember, you calculate the standard test statistic Z. You'll do that by yourself at some point in a more advanced problem, but you know, it's like if Z turns out to be right of this number in this case, then we'll reject. Okay, that's just another way to look at it. So I know that this question sounds like it doesn't sound like the others, but it's just another way to think about it. It's not like it really changes the math. Okay. So here's what I would do to solve it. I need this to be 0.07, okay? Because remember, I would reject if P, the area of this region, was less than or equal to alpha. So it's like at the bare minimum, I can let it be alpha, okay? So set to alpha is equal to 0.07. All right. And then I'll find this number, which would start this region off where the area is such that it's 0.07. That shouldn't be too hard to do. We do that with StatCrunch. Let's see, right-tailed test, I'm going to set this greater than, and this time I'm setting the area to be a desired number, 0.07. Set it to alpha. Okay, 0.07, and I get it. And it says, well, that number is 1.4757. Okay? All right, 1.4757. So that's why here I found that to be 1.48. So that would be the critical value, 1.48. Okay? So here I found it. There we go. That is 1.48. So any number for the standard test statistic that's right of 1.48 would amount to this area being less than 0.07, and it would be less than, P would be less than alpha, and you would reject, okay? So that's the conclusion. It's like I said, it's not really that different than those first few problems, but it is another way to turn the information around. Okay, so I say there's your critical value. And what did I also say? I said, well, we'll reject if z is bigger than that number. Okay, all right, so notice my answer on the second part, reject if z is bigger than 1.48, okay? And, well, what would that look like? Well, like this, like that picture I already showed you. Like, there's that critical value, and like here, over here, if you find yourself over there, then you're going to reject the null hypothesis, okay? All right, now I just kind of have to plead with you at this point for you to see that that's just, it's another way to understand all this, that you can either calculate the area P based on whatever the standard test statistic is, okay? And if P is less than alpha, reject, or you can find the critical value that's, establish this such that it's less than alpha, and then reject if z's over there, okay? It's like they're not really any different. More than anything, I'd like you to see that they're just different ways of expressing what's happening here. Let's try one more though, okay? All right, so this would be question 6 where we have a two-tailed test, okay? And here we have a two-tailed test, alpha 0.09. It says find the critical values and the rejection regions and what's the picture gonna look like, okay? Well, here's what the picture is going to look like. I decided to start there. And I guess you could say that the critical value is, like, could be right here. All right, and that's what we're looking for. And if you find yourself out here, you'll reject the null hypothesis, or you could say it's that one. And if you found yourself out here, same thing. You would reject the null hypothesis, okay? All right, so I'm given that alpha is 0.09. So what I need to do this time to establish the rejection region is set this area to half of that. Okay, so why is that? Well, it's the nature of the two-tailed test. That, another way to turn it around, based on like the way we started the video, is that you have two-tailed test. This area is P over 2, and this area is P over 2. If you double that, you get P, the P value, and if that number is less than alpha, you reject the null hypothesis, okay? All right, so I'm setting it up because that's the way it is, all right? Based on the scenarios of hypothesis testing, this one being the two-tailed test. So if you tell me alpha is 0.09, I'll divide that by 2, I'll get 0.045. And I need to set up my normal curve so that this is 0.045 and then find this number. So again, like StatCrunch would make that really easy to do. Okay, And I could do it on the right, or I could do it on the left, like, because there are two rejection regions, but let's just stick to the one on the right. Like this number, this other critical value is just going to be the opposite of that one. Okay, so I need to find the probability of whatever that number is with this area being 0.0 or 0.045. Okay, so that's what I said, right? Right? Yeah, I need this area to be 0.045. I need to find what that is. So it says that number right there is 1.695. Okay, all right, so I found it, 1.69. So there's that one, and this one will be negative 1.69. All right, and we would reject the null hypothesis if the test statistic was bigger than 1.69 or less than negative 1.69. These are the rejection regions. Okay. Now I emphasize again, like it's just another way of turning it around. If z's out here, then the area is going to be less than alpha in the end. Okay, so it's either you calculate the p-value and it's less than alpha, or you calculate the critical value, and if z is to the right or to the left of it, then p will be less than alpha. It's like another way of like getting to that same conclusion. Okay. Okay, so that's why like here I put negative 1.69. Okay, or sorry, the critical values are negative 1.69 and 1.69. Like I said, I would want to reject if z, the standard test statistic, is less than negative 1.69 or greater than 1.69. That represented like being out here right of 1.69 or being out here left of negative 1.69. And that would look like this, right? That's like the original picture I had up to guide my thinking looked like this to begin with. Okay, so those are the scenarios of hypothesis testing. And all our math for the more advanced scenarios will be based on these scenarios as I've written them out and the way that I found my numbers along the way, like the way I found the critical value if I found that, or the p-value, the area in the tail. Like it's going to be based on that. So if we come down to do a more complicated question like question 12, where we have an actual more or less scientific study with data and so on, then we're going to find everything that way and make our conclusions the same way. Okay, but so far in this video you've been exposed to just the math, and we'll take it a little further beyond that and do the more complicated questions next.